about that. Okay, so today's topic, these slides are designed by Ruth. And so today's topic are factorials, combinations, and permutations. So this is a super cool topic. So let's get started. Ruth, you can start off.
Okay, so say you have 5 friends and you're at the movie theater. So how many different ways can you arrange these 5 friends in 5 seats? Yeah, so to do this, you would use a factorial, which is basically written like a number with a parenthesis. I mean, with an exclamation mark on it. And so that's the equation you use to solve the problem. 5 times 4 times 3 times 2, which is 120.
So now let's do a little bit of practice with factorials, just in case you don't already know what they are. So what's 3 factorial, guys? Yeah, so I see you guys are really spamming in the chat. So yes, so 3 factorial would be 3 times 2 times 1. So basically this factorial, the exclamation mark symbol thing, it just means to multiply all the integers that are like less than or equal to itself all the way down to 1. So 3 factorial would just be 3 times 2 times 1, which is 6.
Next is 4 factorial. So what's that? Yeah, so people are getting the right answer. So 4 factorial is just 4 times 3 times 2 times 1. And another way you could think about it is 3 factorial times 4.
Okay, now 7 factorial. And I guess if you really want to, you could use a calculator, but I don't think you actually need a calculator for this because you should be able to multiply this out by hand. Yeah, or just memorize it. It's good to have like the first few factorials memorized. So 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And so that would just be 5,040. So yeah, or you can memorize it if you don't want to multiply it out.
Next is 10 factorial. Does anyone know what that is? Yeah, so 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is that number, a very big number. And so,
yeah, you can go, sorry.
Yeah, so notice how it gets really big. Like even though 10's not that big of a number, 10 factorial is a really big number.
Also, if you don't have a calculator, like, and there's actually sort of a little quick way to like find a factorial of a big number. So, but you have to have the first few factorials memorized. So if you notice 10 factorial, like let's say you memorized what 7 factorial was, you know that 7 factorial equals 5,040, but you don't know what 10 factorial is. So the way you can use that to help you calculate 10 factorial is that you can notice that 10 factorial is actually 10 times 9 times 8. And then the rest of it is just times 7 factorial. And since you already know what 7 factorial is, you basically already jumped to almost like the end. So you can use that to help you to multiply faster. So that's just something to notice. Okay, so now this is a little bit different. So now you're still at the movie theater, and there's 5 friends, right? But there's actually not enough seats for them. There's only 3 seats. So how many ways can these 5 friends be put into 3 seats? And by the way, there's only like 1 person per seat. There's no like sitting on top of people like nonsense. So 1 person per seat. How many ways can you put them into 3 seats? So for this question, we're going to use something called a permutation. And basically, last week you learned about like the what's it called? Fundamental theorem of counting, or was the fundamental counting theorem? Either way, this is basically what this is. A permutation is in like, well, actually, basically permutations are just are very similar to the fundamental like counting theorem or fundamental counting principle. That's what it was. So for this one, you can like draw 3 lines that represent each of the seats. And so for the first seat, you would have like 5 possible people to sit there. And then once one person has chosen their seat there, then you have 4 people that can sit there. And then the next seat would have 3 people to sit there. And this thing is called a permutation, and we'll talk about it more on the next slide.
I had a question.
Yeah.
Would it work if you flip the same thing over? So like if there were 5 seats and there are 3 people, would you still get the same answer?
That's actually a good question. Let's see. If we have 1, 2, 3, 4, 5 seats, and we have 3 different people, A, B, and C, that wouldn't exactly be the same, because what I would do is that first I would actually use something else called a combination to choose which 3 seats I want to sit in. And then I would arrange the people within those seats. So that would be a little different, but that's a good question.
Thank you.
Yeah, but right now this is called a permutation. So this is the symbol for a permutation. It looks a little bit complicated, but it's not actually very complicated. So basically a permutation, for example, if you have 5 people who want to sit into 3 seats, this is how you say like 5 people put into 3 seats. And that equals 5 factorial divided by 5 minus 3 factorial, which is 2 factorial. And that is basically the exact same thing, 5 times 4 times 3. However, it's just in a sort of a complicated form. But basically just know that if it's something like 5p3, it's just 5 times 4 times 3. Or if it's like 5p2, it's just 5 times 4. So this formula can be a little bit complicated, but it's not actually very hard. Wait, Ruth, are you talking? I'm not sure I can hear you.
Oh no, I'm not talking.
Okay.
Yeah. So does anyone know what 4p3 is?
I think you guys are getting this confused with something else that we're going to learn later.
Yeah. Okay, yeah, so the answer is 24 because it's 4 times 3 times 2.
And you can think about it like this. Yeah, it would be 4 factorial times 1 factorial, because if you use like the complicated formula we showed, this would be like 4 factorial divided by 4 minus 3 factorial, which is like 4 factorial divided by 1 factorial, which is just 24. You can also think of it like the second number here, like tells you how much to multiply down. So it would be like, in this case, it's 4, but multiplies 3 numbers down. So 4, which is the first number, times 3, which is the second number, times 2, which is the third number. So now try the permutation 7p4. So this would, for example, this could represent something like you have 7 cards of different colors and you want to like arrange 4 of the cards one by one in order. So that would be like the situation that this could represent. Yeah, so this would be 840 because 7p4 is 7 times 6 times 5 times 4, which is 840. So this is applying, like, for example, if you have 7 cards of different colors and you want to arrange them in order, then the first card you would have 7 ways to choose. The second card you would have 6 ways to choose. The third card you would have 5 ways to choose, and the fourth card you have 4 ways to choose. So there would be like 840 ways to do that. Okay, Ruth.
So now do 10p1, and this one's really easy. You don't need a calculator for it. Yeah, so basically anytime the second number is 1, the first number is the answer.
Yes. And this is a good way to think about it. If this sometimes confuses you, think like how many ways can you arrange like 10 people in one chair? Well, because there's like 10 different people that could sit in it, then there's like 10 ways. Or I guess you could stack all of them, but like that's not a thing in this like math question. So okay. And this one, 4p4. This would be like how many ways are there to like arrange 4? Okay, think about it like this. How many ways are there to arrange 4 people in 4 chairs? Is it 1? Are there like, is there just one way to arrange 4 people in 4 chairs? Yeah, so the answer for this one would be 24, because again, this is how many ways to like arrange 4 people in 4 chairs. So for the first chair, you would have like 4 people that can sit in it. The second chair, you would have 3, and then times 2 times 1. So just as a reminder, that in a permutation, the second number tells you how many times to multiply down. So 4p4 would be 4 times 3 times 2 times 1.
Wow, it sure is May out here.
Looks like someone's watching YouTube.
Yeah.
Okay, so now it's the same as before. So we're still putting 5 people into 3 chairs, except this time the order does not matter. So meaning if you have like a friend, Sarah, Becky, and Rebecca, then having Sarah, Becky, and Rebecca in that order is the same thing as having Rebecca, Becky, and Sarah.
So for example, it would be like it would sort of be like choosing out like clothing, right? You can just choose like, if you choose like red pants, like if you choose like red pants and a blue shirt and like a green hat, that's the same thing as choosing like a green hat, a blue shirt, and a red pants. So as another example, it would be like, here, let's use some props. If I had like a pencil, like a mechanical pencil, and I had like this highlighter, and I had like this pen, it's just like an array. I just like have these objects. I'm not arranging them in any order. It's just this particular combination of things that matters. So for example, if I held it in this order, it's like the same as if I like held it in this order. But if I like swapped out this pen for a different pen, then it would be a different arrangement because I've actually swapped out one of these things for another. But I can like put them in any order I want, and it's still the same like combination. So that's what a combination is.
Pablo,
So this is like the formula for a combination. And I think this is what you guys were trying to do earlier. So for example, if this were like a combination for like the question where like, except this time like the order does not matter, then it would be five chairs, five and then choose 3. So this one, it would be, so 5, we use a C to indicate the choose. So it'd be 5 choose 3. That equals 5 times 4 times 3 times 2 times 1 divided by, and then this kind of looks confusing. So 3 times 2 times 1, and then you multiply 5 by 5 minus 3, which is 2 times 1. However, you can sort of simplify it because this part just cancels out. So I think an easier way is to do like 5 times 4 times 3 divided by 3 times 2 times 1. So that's a combination. So that would be 5 choose 3.
It's basically of the permutation, except like multiplying 1 over r factorial.
Yeah.
So what is 5 choose 3? Yeah, so people are getting it. It's 10.
Okay. So now what's 6 choose 4? So for example, if I had 6 marbles and I wanted to choose like 4 of them out of the bag, how many ways would there be to choose those 4 marbles? So that would be 6 choose 4. Yeah, so the answer is 15. So this would be how I would like write it out. So 6 choose 4, so 6 times 5 times 4 times 3. Notice that there's like 4 numbers on top, divided by, and then 4 factorial on the bottom. So 4 times 3 times 2 times 1. So then this would just be equal to 20. So therefore, so if I had 6 different marbles in a bag and I wanted to know how many ways I could choose any 4 marbles out of the bag, then there would be 20 different ways to do that. Oh wait, shoot.
Shouldn't it be 15?
Yeah, it would be 15. Whoops. Let's do the math again. 6 times 5 times 4 times 3 divided by 4 times 3 times 2 times 1. Yes, it would be 15. Sorry. You guys caught me.
So now what's 7 choose 5? Yeah, so it's 21.
Okay. And then this one, 3 choose 3. What would that be? Yeah, that's right. So 3 choose 3 would just be 1, because on the numerator it'd be 3 times 2 times 1, and the denominator would just be 3 times 2 times 1 again. So they just cancel out and become 1. So that would be like if you had I don't know, 3 like different coins and you wanted to know how many different ways you could pull out 3 coins. Well, since there's only 3 coins in the bag, there's only one way you can do that, which is by pulling out all the coins at once. So that would be like a situation where this sort of,
I had a question.
yeah.
Is there any way the number could be, the answer could be a decimal?
Not really, because typically we only use like whole numbers here, because I mean, I don't know what it would really mean if it were like a decimal, because like normally a factorial would only like apply to like or non-negative integers. So this one really applied to decimals. But I'm sure like there's like some like, if you like plot the factorial graph, like if I can like go into decimals and show you really quickly, but if you plot like the factorial graph, you can actually see decimal factorials. So for example, if I plot x factorial, this is like a factorial graph, right? So you can actually calculate 0.5 factorial. So it's like with 0.886. But like typically that doesn't like apply to these problems because you typically only use like factorials when you're like talking about counting. So like counting coins and like counting fruit, or not fruit. Well, I guess you could have fractional fruits, but typically we talk about it when counting discrete stuff. So like things that can't be chopped in half. So generally like fractions wouldn't like apply, if you know what I mean.
Okay.
But yeah. The graph works by using calculus to extrapolate between. So in other words, I don't really know, but it uses some complicated math.
So the first activity, so basically we'll give you a problem and say whether you should use factorials, permutations, or combinations to solve it.
Okay, first question. Sarah's chat coach wants to know how many different possible orders like his players can finish in. So would you just use a regular factorial? Would you use a permutation, or would you use a combination? Now, technically permutations like use factorials. So yeah. Okay, I see you guys are using.
Oh my fucking god.
So for this one, I see you guys are putting permutations in the chat. On the slides we have factorial. However, I
think it might be because they might think it means like place in first, second, and third place.
Yeah. So like, I would say like permutation would be fine just because the order does matter, and it would also use like a factorial too. So like, for example, like this would be like in effect, if there were like 10 players in the race, it would be like how many ways they could finish would be like 10 factorial. But if it were like, but you could also do it with like a permutation too by do 10p2 or 10p10. So I would actually say both are correct because you can use a factorial, you can use like just a normal factorial as well as like a permutation. So everybody who put permutation and factorial, I would think it's okay.
So Lucy is trying to arrange her books and wants to know the possible ways to arrange them into 3 slots where order doesn't matter. Yeah, so the answer is combination, and the key word is that order doesn't matter.
Yes. Okay, last one. How many ways can 20 cars park into 10 slots where order matters? Okay, once we finish this question, I can explain combinations again for the person who requested it. Yeah, so this one would be a permutation because you're parking, because the big keyword is like order matters. So that means like the order that they park into the spots matters. So this would be a permutation. And for the person who asked about combinations, so basically what a combination is, it would be like if you like had like, let's say you had a bag of candy and every piece of candy in the bag was different, right? So you want to like choose 5 like pieces of candy from the bag. And so a combination problem would be like, how many different combinations of 5 pieces of candy can you pull out of the bag? So you could like pull out like a piece of red candy, yellow candy, green candy, blue candy, purple candy. but the order that you pull them out doesn't matter. They're just like, you're just holding them in your hand. It doesn't really matter like what order you like pull them out in, if you know what I mean. So versus like a permutation would be like you want to pull out first a piece of red candy, then you want to pull out a piece of yellow candy, then you want to pull out a piece of green candy. So like that would be sort of like a situation where order matters. And another example would be like, for example, I want to know how many ways I can arrange the letters in my name. So A-M-Y. So in that case, A-M-Y would be like one ordered arrangement of the letters in my name. And so Y-A-M would be a different ordered arrangement of the letters of my name. So these two would be different in a permutation. But a combination would be like, I just want to choose two letters from my name. So for that, I could choose like A and M. I could choose like Y and A, and I can choose like M and A. But the order that I choose them doesn't matter. They're just like an agglomeration. So they're just like chosen together. Does that make sense? Okay. There's a rainbow outside. It looks like there would be. Is it like a big rainbow? Okay. So we have a Kahoot. So yay.
We're gonna do a Kahoot for 28 minutes.
Well, if we finish the Kahoot, we can do another Kahoot and we can do bonus problems too.
If we finish the Kahoot, can you let us go early?
No, because I don't know if you knew about this, but class ends at 8 p.m. So if we finish early, class has not finished yet. So we can't let you go.
I thought you were supposed to be high schoolers. You're supposed to be fun.
We can be fun.
Actually, that's true though.
We can do another Kahoot if we have time.
Can we do one not related to math?
Okay, we could do that. It depends on how well you guys do on this Kahoot though. If you do really bad, then we might need to do another Kahoot.
Is it put on so that we can see it on our screens or no?
Second, sorry, can I join? I just have to get my iPad.
I'm using my phone. So
that's okay. Can't you like click? Like using your like finger?
who, me?
To the person who's saying like they don't have a mouse.
Oh.
Oh wait, I can like put the settings so that you can see the question on your. Oh wait, it's already on. Okay. So you should be able to see the question on your screen. If you can, then I don't know. Okay, hurry up and join so we can start.
Honest ujos, what the heck?
Okay, I'm just starting, guys. I'll put like the link back in the chat. So.
Wow, Sinob.
Okay, permutations and combinations. Okay.
Yeah, I got that, Sinob.
If the order is important, then you have to perform A.
It's yellow.
Yeah, but it's totally yellow.
It's red because order matters.
Well, there's a thing called sarcasm, you know.
What's the code? Like, it logged me out of my iPad. Can you just tell me out loud?
Yes, 621 5333. Yay! I think it looks like most of you guys got it right. So permutations will be if the order matters. So, for example, the letters in my name is like an.
When I said it was yellow, I thought it was actually yellow, and I clicked yellow.
Well, maybe the people who chose yellow misclicked. Evaluate this factorial. Yay, almost all of you guys got it correct. So 4 factorial is 4 times 3 times 2 times 1, which is 24. I have a tricky question for you guys. So what is 2 factorial, 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 factorial? Evaluate that. So for this one, like use like the parentheses like this.
2.
Yeah, you guys got it. Why? It's because 2 factorial is 2 times 1, which is 2. So this just becomes 2 factorial over and over again, which is just 2. So yay. Factorials are cool. Evaluate this factorial.
Oh my god, I'm so stupid. I thought I panicked, and for some reason I thought 3 factorial was 3. I'm such an idiot.
Oh no. Yeah, Daniel. Yes.
I
if
quit
you're
the
three-
Kahoot.
Oh,
There's no
no.
way I'm recovering from this.
You know, everybody probably misclicks like once, or maybe comes close to misclick. So I believe in
Yeah,
you.
I was
It's still
second place
helps.
before, and now I'm 20th place.
You were only 3 questions in, Colin.
I'm absolutely crippled. I cannot recover.
Think about like if you're in the movie theater, right? There's 4 people and there's 2 seats. Okay, so for this one, it would be the number of like picks. Like you're picking. So like if you're in like the movie theater and there's 4 people, and then it's a permutation, right? Which means that there's only like 2 seats, and so there's going to be 2 like blanks, and you need to fill in those blanks with the people that you're choosing.
I am 2 points behind Hee Haw.
Dang, bro.
Oh my gosh, everybody got it correct. Good job, guys. That's amazing. Okay, find the number of permutations. Remember, this is a permutation, not a combination or anything else, a permutation. Yay. Okay, looks like most of you guys got it right. So for P2, it would be something like you have 4 people and they need to sit into 2 seats at the movie theater, and order matters. So that would be 4 times 3, which is 12. number of permutations.
Why are you drawing around the P?
I don't know. Well, actually, it's just because I can.
Nice logic. What I do is I'm bored. That's what I do.
Oh no, who has access to the drawings then? Oh wait. Oh, it was because Kayang enabled it for you guys. Yes. Okay, so yes, the answer is 6. And yeah, 3 times 2 times 1 is just 6. Yay. Okay, find the number of permutations in this. I assume that's a 6. Ruth, is this a 6?
Yeah, 6 and 0.
Okay.
That looks like a very nice B though.
Yeah. Definitely. Oh yeah, it kind of does look
have a
like the
question.
logo.
Do
Yeah.
you have to pay to make all these cahoots?
No, there's like a free like Kahoot
Yeah.
account. So
I
And
have one.
I think now if you go, you can only make a Kahoot with 3 people max.
oh really?
Yeah, you gotta pay for that now.
That's interesting.
Unless you made Kahoots in the past.
Maybe that's why. Okay. So 6 choose 0. Looks like a lot of you chose 0. So think about it like this. So you
I
have
actually got it right.
On what it means by permutations.
wait,
I got
what
it
was the
right.
question?
I'm confused on what it means by how many permutations.
Okay. So I like to think of it like through a different like
Hey
lens.
Siri,
So like if you
what's
have
6 divided by 0?
6 people like that are
I
going to
checked with the
movie theater.
calculator, and all it says is undefined. It's not what you.
So if you have 6 people going to movie theater, right? But there's no seats, then how many ways can you sit down? What was
0.
that? I would think 1 because the only way you can like arrange yourself is by not sitting down, but I could be mistaken.
That's confusing.
Okay, well this might not be a good question then, so that's
I
okay.
just randomly pressed something.
Can you give an example? Oh, okay.
For-
Well, never mind.
For this question,
It's fine. Just move on, I guess.
okay. All right, find the number of combinations.
My screen is stuck on the correct thing. It's not moving.
Uh-oh. Try to refresh.
Could you explain what it means by combinations and permutations again?
Okay, so a combination would be like if you have a combination is an unordered set of objects.
I know
A
that, but, like-
permutation,
Like, what is it like when it says find the number of combinations?
yeah,
Is that
it's
just asking
asking you
solve?
to evaluate this. So
Okay.
this would be like 4 choose 1. So you have 4 different like marbles in a bag and you want to choose 1 marble. So how many ways would you do this? How many ways would you do that? Okay, so this one, 4 choose 1, would be like, for example, you have 4 marbles in a bag. How many ways can you choose 1 marble out of the bag? So that would just be 4. Okay, here's another one. 4 choose 3. So you have 4 marbles in a bag. Now you want to choose 3 marbles out of the bag. So just evaluate like this combination. Okay, so looks like most of you guys got it correct. So 4 choose 3 would be 4 times 3 times 2 divided by 3 times 2 times 1. Just, oops, that's the multiplication sign. So just always remember like that. And I don't know if you guys noticed, but you may notice, I don't know if you have, but 4 choose 1 and 4 choose 3, they have the same answer, right? Do you think that's a coincidence, or do you think it's not a coincidence? I mean, you probably know now that it's not a coincidence because I'm specifically asking about it. But yeah, it's not a coincidence. So basically, the thing about like combinations is that like there's actually like, notice how like the second number, like 1 and 3, they add up to 4, right? So now let's look at like 5 choose 2 and 5 choose 3. What's 5 choose 2 and what's 5 choose 3?
5.
5 choose 2 would be 5
10.
times 4 divided by 2 times 1. So that's 10. And then 5 choose 3 would be 5 times 4 times 3 divided by 3 times 2 times 1. And so they both equal 10 actually. And again, the second number, they together add up to 5. Let's see. So you may notice that like when you like these, like the 3's cancel out, which is why like they're equal. So basically, if you ever have like this is sort of like a property of combinations. If you have like n choose k, that is equal to n choose like, and then n minus k. Lots of variables, but all it's saying is that the second numbers, they add up to equal the like first number. So for example, if I told you 6 choose 2 is like, I don't know, 15, what would 6 choose 4 be? Well, since the second 2 numbers add up to like 6, you immediately know that that equals 15. So I could do that with like some gigantic like number, I don't know, like 100 like choose like 3 or something. I don't even know what that is. But once you know what 100 choose 3 is, you also know what 100 choose 97 is, because these two add up to 100, so they're equivalent. So that's something that can come in handy. Okay.
Good question. What group is the Gremlins?
Gremlins is like, I'm pretty sure that's like 5th through 6th. And then dragons are like the 7th through 8th.
So the
Gremlin is like, I'm actually not exactly sure what a gremlin is.
I'm pretty sure
I
it's a
know,
goblin.
yeah, I think it's something like that. All I know is that there's a movie titled
So you-
Gremlins.
So you know, to call the 5th and 6th graders, like the short ones, Gremlins.
Yeah.
What's the point of a class name even?
It's because then we don't need to, it's just fun. Like, I don't know, it's just fun. And also sometimes it's easier to say gremlins than like 5th through 6th graders. Like gremlins is like 2 syllables, and then 5th through 6th graders is like 5. So Okay, would you perform a permutation or a combination for this? Oh my gosh, I've heard that joke before. The night round table thing. There's like a whole book about it, like about that pun. Like the pun is literally just like those two, like the knight and like the king just going into the forest and chopping down the tree. Okay, I'm giving you guys 5 more seconds to answer before I'm just going to skip it. So if you haven't already answered, you're going to have to just choose a random answer. Okay. So four swimmers enter a race. How many ways can they finish first, second, and third? So for this one, the sort of giveaway is that it's asking first, second, and third. And first, second, and third is like order matters. So permutation. Okay, I'm giving you 5 seconds. Whoa. How did so many people choose combinations? Oh my goodness. Okay. So there's 4 people, right? And this is like talking about line up in a row. And since they're lining up, the fact that they're lining up means that they're like going in order. So this would be a permutation. Okay, let's try to hurry because yeah. Okay, I'm gonna go fast now. Okay, 5 seconds. Okay. So for this one, you would do a combination because again, you're choosing a group of people, you're not ordering them in a specific way. So that would be a combination.
I just put it because it has the most C's.
Wait, could you say it again?
I put it because there are like a lot of C's in it and combinations. C.
Yeah. Oh. Would you use a permutation or combination? Remember, you're not actually like solving this problem. You're just saying if it's like permutation or combination.
It's 50-50.
Make a joke about permutations and combinations.
How? My math teacher is good at the jokes. Well, my last year math teacher at least.
Okay, looks like most of you guys got this right. Okay, we have one more, and then I have a bonus question for you guys. Although some of you guys might already know how to do it. Okay, so this one, I would say it's a permutation, um, but I'm not fully sure, because I guess you could argue either way, because it could be a permutation or it could be a combination, but yeah. Okay. Oh gosh. Okay. There is no test, guys. I don't know what that was. There's no test, just this.
Quick question. Did you copy this off of a teacher?
I did not make this Kahoot. I mean, I didn't make this lesson, so. But yeah, good job, Shlok, Advika, and Erica for doing very good on this Kahoot. And now I have a bonus question for you guys. So this is a question, and you have to use the skills that we learned today to solve it. Or you could use your drawing skills to solve it, but whichever one. So how many ways, what's the maximum number of intersections between 57 lines drawn on a paper? So for
Can you write
example,
that down?
okay, I will, I'll type it out. Maximum number of intersections between 57 lines drawn on a piece of paper. Straight lines, by the way. So this is the question. So for example, if you have 2 lines, right, then there would just be like 1 point of intersection. If you, that because that's like the maximum. If you have 3 lines, you can have a maximum of 3 points of intersection. If you have 4 lines, hold on. There are a maximum of 6 points of intersection. And if you have 5 lines, this is becoming very hard. 1, 2, 3, 4. Okay, if it's 5 lines, there's I don't know how many intersection points is that, but this is the little bonus question. So let's see who can solve it. Let's see the answers so far. 67 factorial, 56, 57 factorial, 56, 57. Okay, well, I have not seen any right answers yet. Just saying. Actually, let's see. I think some people are getting it. Okay, let's see. Shlok, you're the first person to put something that wasn't like 56 factorial or 57 factorial. Do you want to explain your answer?
Yeah, sure. So basically, I was thinking like we could do 57 times 56 over 2 factorial. So I just thought of that because like it's the greatest possible number of intersections of 57 lines. So instead of just simply doing 57 factorial, I just did 57 times 56. Like it's kind of like a combination I did.
Okay. Well, guess what? You're right. So the answer, I sort of like to think of it this way. So like an intersection, like in order to maximize the number of intersections you have to have every 2 lines have to intersect. Like you have to have every 2 lines intersect in order to maximize the number of intersections. So you're basically changing the problem. So now you're asking yourself, how many combinations of like 2 lines out of 57 are there? So in other words, calculate 57, choose 2, because the number of like intersections would be like, out of the 57 lines, how many ways are there to choose 2 lines? And then you mentally make those 2 lines intersect each other, and then boom. So it would be 57, it would be 57 choose 2, which is just 57 times 56, oops, divided by 2 times 1, which is 1,596. So yeah, that is your bonus problem. and it's basic. It's 8 o'clock. It's almost exactly 8 o'clock now.